Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is ground freezing. In ground freezing, it is the one of the geotechnical technique we are going to understand in cold regions and the snow regions, how the ground freezing, how we are going to overcome those ground freezing effects using this technique for getting the soil desired properties as per the requirement of the construction work. In ground freezing is a geotechnical technique used to temporarily or permanently stabilize soil and groundwater conditions. Using this kind of ground freezing, we are going to use this technique for temporarily or permanently stabilization of the soil and groundwater conditions. By lowering the temperature of the ground below freezing, soil and water transform into a solid mass of ice which provides temporary support and impermeability. This technique is valuable in construction, tunneling, mining operations, particularly in environments where other stabilization methods might be ineffective or impractical. So, some of the stabilization methods we have for stabilization of the soils, in those methods it is impossible and they are ineffective. Practically, it is difficult to conducting the stabilization methods in particular regions. In that particular condition, we are using this ground freezing technique. In this ground freezing technique, we have to understand this technique is for underground. In most of the cases, we are using these underground constructions work like tunneling and mining operations. Principles of ground freezing. Coming to the principles of ground freezing, the core principle of ground freezing is based on the thermodynamic process. Based on the thermodynamic process of extracting heat from the soil, thereby lowering its temperature below the freezing point of water, that too in between 0 degrees Celsius or 32 degrees Fahrenheit. It depends upon that temperature below the freezing point of water. Below the freezing point of water, 0 degrees or 32 degrees Fahrenheit. When soil moisture freezes, it forms ice which bonds soil particles together, creating a solid and stable mass. In this, ice serves two primary functions. The one is stabilization and the other one is the impermeability. In this stabilization, ice increases the strength and rigidity of the soil, providing structural support. In impermeability, frozen soil acts as barrier to groundwater flow, preventing seepage and ensuring a dry working environment. So, we have to understand this ice serves based on these two functions. The one is stabilization, other one is impermeability. So, this core principle is based on the process of thermodynamic process. And we are going to understand after the freezing point of the water. We are talking about the temperature after freezing point of the water. Types of ground freezing. Mainly two main types of ground freezings are there. The one is artificial ground freezing, that is AGF, and the next one is natural ground freezing. In artificial ground freezing, this involves the use of refrigeration equipment to artificially lower the ground temperature. Natural ground freezing utilizes natural low temperatures typically in polar or high altitude regions to achieve the soil freezing. It depends upon the geographical conditions of that particular locality. Based on that natural ground freezing is occurred. In artificial ground freezing, we are using this refrigeration equipment for artificially we are going to reduce the ground temperature using these refrigerators. So this is known as, this type of ground freezing is known as artificial ground freezing. In artificial ground freezing process involves different kinds of steps are involved. In that, site assessment and planning, installation and freezing pipes. In this site assessment and planning, we have to understand the geotechnical investigation. First, we have to understand the soil conditions and what are the desired properties we are required for the construction. These are the parameters we have to understand. Based on this geotechnical investigation, we know and we detailedly analyze the geotechnical properties. It means soil properties of that particular locality. In that, how much moisture content, permeability, strength, stability, soil bearing capacity. These are various different kinds of properties, that plasticity, that liquid limits, and what are the various different properties are involved in that particular soil. That primary things we are going to understand in this geotechnical investigation. And also the groundwater conditions. At what level the groundwater is available, how the movement is there, the groundwater movement, which direction it is there, how it is reacts, and at what level it reaches its depth, at what level the groundwater reaches its lower and higher variations are there. So these are all we are going to understand in this geotechnical investigation. In design parameters, we have to understand the freezing requirements. How much the freezing point, where the freezing point, how much this is required, the determination of the freezing requirements, including the extent, depth and duration of the freezing. So these are all we are understanding in our design patterns. Installation of freezing pipes. So vertical and horizontal pipes and pipe material. How the direction of the pipe and which type of material we are using is the important parameters in this installation of freezing pipes. In vertical and horizontal pipes, freezing pipes are installed in grid pattern around the area to be frozen. How much area we are going to frozen and where that is located in that overall area, how much place, and these are all the things we are going to understand, and we are going to install in a grid pattern around that area which is to be frozen. These pipes can be vertical or horizontal, it depending on the application. It depends upon the application. It depends upon its application. Pipe material, typically made of steel or other durable materials capable of withstanding at low temperatures. Such type of material we are going to choose for the process of artificial ground freezing process. And circulation refrigerant. In this, coolant sections, cooling systems are involved. Common refrigerants include different kinds of liquid generations, nitrogen, solution of water and salt. Like that we are going to use this coolant selection. That cooling system, the refrigerant is circulated through the freezing pipes, extracting the heat from the surrounding soil and lowering its temperature. Monitoring and maintenance. Temperature monitoring. Sensors are placed within the soil to continuously monitor temperature changes and ensure uniform freezing. System maintenance. Regular checks and maintenance of the refrigeration system to ensure optimal performance. So these are the steps. These are the steps we are going to understand in under the artificial ground freezing process. Applications of the ground freezing. Ground freezing is utilized in variety of construction and engineering projects, including tunneling and groundwater underground construction. For support of excavation and also as waterproofing, we are applying this ground freezing technique in tunneling and under their ground constructions. Support of excavation, ground freezing provides temporary support for tunnel walls and roofs, preventing the collapses during excavation. In waterproofing, freezing creates an impermeable barrier keeping water out of the construction area. Mining operations, shaft sinking and groundwater control. In mining, this ground freezing is applied to freezing stabilizes the ground during the sinking of the mine shafts, ensuring safe and dry conditions. In groundwater control, prevents groundwater from entering this mining area, which is crucial for safe and efficient operations. For this purpose, we are using this ground freezing technique. In environmental remediation point of view, for contaminants, soil stabilization. In contaminant of contaminants, ground freezing can isolate and contain contaminants, preventing their spread during cleanup operations. Soil stabilization provides temporary stabilization of contaminated soils for safer handling and treatment. In infrastructure projects, bridge and dam construction ensures stability and prevents water ingress during the construction of foundation for bridges and dams. In pipeline installation, stabilizes the ground for safe and precise installation of pipes. So, these are the some of the applications where we apply this ground freezing. Advantages of ground freezing, temporary and revisable. Ground freezing can be applied temporarily and revised when the project is complete with minimal long-term impact on the environment. It is suitable for various soil types and conditions, including loose, saturated and contaminated soils. Creates a reliable barrier against groundwater, ensuring dry and safe working conditions. Non-intrusive, does not require extensive excavation or disruption of the site, making it ideal for urban environment. So, these are the some of the advantages of ground freezing. As per the cost and energy, time consuming, environmental impact are the some of the disadvantages for this ground freezing. The process can be expensive due to the high energy consumption and need for the specialized equipment. For this specialized equipment and the process of high energy consumption means it leads to the non-efficient, non-economical. It means it is costly. So this is the one of the disadvantage in ground freezing. It depends upon the project requirement. In sometimes that project may not bear these equipment costs and the specialized equipment cost, or it increases the project cost also. So this is the one of the limitation we have in our ground freezing. And also it requires continuous energy input to maintain that particular frozen state. For maintaining that frozen state, the continuous energy input is to maintain, which can be limited factor in remote or resource. Some of the remote locations, it is difficult to maintain. So that type of energy intensive also we are going to understand in this. We are facing such kind of issue in ground freezing whenever we are using this technique. And also time consuming. The freezing process can take several weeks. It took some time. It depends upon the how much region is going to be frozen. Based on the soil condition also and which type of process we are using and also how much energy we are spending and continuously we are maintaining or not. Any deviations they may occur in between this continuous supplying of the energy. So these are all the problems we are going to face, and it took some time for getting the soil frozen. So this is also one of the factor for consideration as a limitation we are going to consider in ground freezing technique. Because of this delay, it took some times, means it is lead to the project, potentially dealing the project timelines. It may affect the project timelines. In environmental impact, potential for environmental impact due to the use of refrigerants and other energy consumption. This affects the environmental also. The environmental impact is there for using this ground freezing. We have to take certain precautions, and based on the cautions we have to work. Then only this environmental impact is going to reduce. We have to consider this impact also whenever we are using this ground freezing technique. Case studies and practical considerations. Tunnel construction in urban area. This is the one of the case study. Just outline of the case study we are understanding here. Construction of a subway tunnel, a busy urban region. In urban region, we are going to plan a subway. In these challenges, high groundwater levels and unsuitable soil conditions are there. So this is the challenge of this tunnel construction in urban area. Solution is ground freezing was implemented to stabilize the soil and create a waterproof barrier. So because of the high groundwater level and unstable soil conditions, the remaining techniques are not that much effective in this particular challenge. So in this region, we are going to choose this ground freezing technique to stabilize the soil and create a waterproof barrier for the construction of the tunnel work. These freezing pipes were installed around the tunnel perimeter, and it was also circulated to achieve the desired soil conditions. Results: the frozen soil, adequate support and prevented water ingress, allowing for safe and efficient tunnel construction. In mine shaft sinking, one of the project overall we consider sinking of a new mine shaft in an area with loose and waterlogged soil. So in that challenge is high risk of soil collapse and groundwater intrusion. So in this particular, the solution is in ground freezing technique, that is artificial ground freezing was used to stabilize the soil. Vertical freezing pipes are installed around the shaft perimeter and liquid nitrogen was used as the refrigerant. Results: the frozen ground provided a suitable and dry environment for shaft sinking, ensuring the safety and success of the operation. So these are the case studies we understand in better understanding about the ground freezing technique necessity. In practical considerations, site-specific condition, monitoring and control, environmental and safety refrigerant regulations, cost management are the practical considerations for ground freezing. In each project, in site-specific conditions, each project requires a well-approached based on the specific soil and groundwater condition. Detailed geotechnical investigations are crucial for designing an effective ground freezing system. In monitoring and control, continuous monitoring of soil temperatures and system performance is essential to ensure uniform freezing and address any issues promptly. Environmental and safety regulations. Adherence to environmental and safety regulations is crucial, particularly regarding the use of refrigerants and energy consumption. Cost management. Effective cost management strategies, including energy efficient refrigeration, systems and optimized freezing durations can help mitigate the high costs associated with ground freezing. Finally, based on the overall summary, based on the case studies, what are the limitations, based on the advantages and what are the various types of this ground freezing, it is a powerful and a versatile technique in the field of geotechnical engineering, offering reliable solutions for soil stabilization and groundwater control. By understanding the principles, methods and the applications and their practical considerations, engineers can effectively implement ground freezing in various construction and mining projects. Despite its challenges, ground freezing remains a valuable tool for ensuring safe and stable conditions in complex and challenging environments. These are the sub-web references for understanding these ground improvement techniques. These three are gives better understanding about the ground improvement techniques and their methods and their techniques also in detail. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.